Oh no! No, sigma. Can we just turn the sigma 90 degrees?
Yes, I did.
What is the letter it looks different from your regular style.
It's Greek.
Sometimes I switch it up. Oh man, I didn't.
Why is it start with an S?
Why
Why is it not like Eggman?
Eggman. It's
Much
Dr.
better.
Eggman.
Really?
Yeah, just out of the blue, he was like, I really like your font.
What?
And then just nothing else.
I mean, why is the Greek
It is
letter?
February
Why
1st.
is
Can
the
you
third
believe
Greek
it?
letter Jan?
January just like happened, and there was no time.
Well, you were at home for most of
I
it.
know.
No, the
Okay,
proper way
so
is-
let's first talk about the difference between a finite and an infinite sequence.
Why is it not finite?
That's one of my pet peeves is when people say finite.
I'm gonna finish.
So here we have an infinite series where we keep adding and adding and adding the terms of the sequence over and over and over again to infinity.
You can't go
Yes.
beyond infinity, Gabe. Buzz Lightyear lied to you.
What's the little?
Because if you can go
My
beyond,
son's
it's
preschool
not
teacher
infinite.
told him, well, they were talking about numbers, and they talked, and just like in conversation, not like teaching. And then, so infinity.
Well, I mean, technically you can go beyond infinity if you're
Jackson,
going
can
with
you
the
tap
different
these?
That's a
standard
wonderful
of
photo.
infinity. For instance, this is
Hey, look at
this
that.
is Aleph
That's
on
what you wanna
infinity, the number of real numbers.
Anyway, I had to have like
No,
a
the
5-minute
number of
conversation with my
integers
4-year-old about
is
how
an-
infinity
is
is
an
not
Aleph
a
on
number.
infinity.
You
Uh,
can't learn that. Infinity is not a number. Yes.
This the infinities we deal with n are specifically Aleph level 1 infinities, meaning that it's just the number of positive integers. As Aleph levels go higher, it can be like the number of real numbers is a higher Aleph than the number of integers.
Okay.
So Aleph is a fun Greek letter.
Okay.
It's
If
like a weird
we
thing.
have a finite sequence, that means that we'll stop at some value, like n.
Oh, boy.
Okay. So a sub n would be the last term that we add in our summation.
Well, if it has a limit, wouldn't adding it to infinity still give you a value? If it doesn't diverge?
So there's a big difference between converging and diverging sequences compared to converging and diverging
Integral.
series. And we are going to spend the next 2 weeks
Oh,
talking
boy.
about converging and diverging series.
All right.
And we have a list of tests. You've seen Victoria's flowchart, which I have for you when we learn all of our tests.
You have it for right now?
Okay? What?
You have it right now?
Well, not copy for you, no. You don't know them. I'm going to teach you 3 of the tests
That's
today.
okay. I can handle 3 today.
Okay.
We're really glad that you can handle it.
It's gonna have like 7 Greek letters in it.
So, in the rare
Sigma,
event,
Gamma, Beta, Alpha.
Joe, you've been very distracting so far. Let's take it down a notch. In the event that you can actually calculate the sum, how often will that be able to happen? I don't know. In the actual event that you can calculate the sum, then the series can converge. So it says if the sequence of partial sums of a series converges, then we say that the series converges. So here, if I can actually take the sum and figure it out, and we have a limit of the actual sum, then we can say it can converge to that value.
No.
Was it an interview about that?
Yeah. I might have to ask for one of those figures for myself.
Okay, you have a connection to the yearbook.
Yeah.
Go briefly back to the other slide and Jackson's okay.
Hmm?
Go briefly back to the other slide and Jackson's okay.
So this is K equals 1 to N. So this is K. And would equal You wanted it, you got it.
Okay, I felt there might have been more to it and I wasn't really sure.
So are series also sequences?
Series are the sums of sequences.
Which could
But
be
you could
expressed
like
as-
take each partial sum and then make it its own sequence. Like if you added just the first one and then added the first one and the second one and then added the first three. Like would that be considered a sequence?
You probably have a sequence, that'd be like a sequence of a series or something. You have to have like two of the segments. You can make a series of segments.
I mean, I kind of see what you're asking me. Our tests are going to be much less complicated than
I
trying to
was
write
just
our
curious.
own.
I was just
Okay.
curious. That was not like
Okay. I mean, I suppose it would just be thinking about like what the next value is.
Yeah.
I see what you're saying, and
Yeah.
that makes sense. But it would be a lot more work than it's worth, I think.
Yeah.
Okay. Because we're going to be able to do most of these tests in a matter of a couple of minutes. Okay, if that, depending on the test. Okay. So I need to reiterate that S sub n is the actual sum. And if we have a limit of the actual sum, then that is what it would converge to. A famous example is what we call a telescoping series. These are probably some of my favorite sums because of what can happen inside of them. I have lots of favorite things in math, but when we're talking about series,
Well, I mean,
These are fun.
it's always a slightly bigger number.
okay. So let's think about actually doing our sum. Okay. If we talk about the sum from k equals 1 to infinity of 1 over k minus 1 over k plus 1, then when we plug in 1, we get 1 minus 1 half, right? Plus, when we plug in 2, we would get 1 half minus 1 third. Yeah. Plus, when we plug in 3, we get 1 third minus 1 fourth. Do you see what's happening?
the middle is like canceled.
Okay. Well, all the way.
So it would just be
Well, let's think about. Let's go ahead and change this. Let's think about the nth sum. Okay. If we go all the way to the nth sum, then we would have 1 over n minus 1 over n plus 1. Right? So you said what's going to happen? All of the what will cancel out? Like these 1/2 cancel, these 1/3 cancel, the 1/4 will cancel, the 1/5 will cancel, Anything else?
Every number that isn't the first or last number.
Every number that's not the first or last. So, if we had this as a finite sum, it would be 1 minus 1 over n plus 1. Okay. So what this theorem says that we can do is, well, if you can find the nth sum, the nth partial sum of an infinite sequence and take its limit towards infinity, then it converges to that number. So what we can do is we can take the limit as n approaches infinity of 1 minus 1 over n plus 1 to be 1. So we can say that this series converges to 1. Ooh. Because it's a telescoping series. Anytime you come to the conclusion of a series either converging or diverging, you have to tell me why. How do you know that it's converging or diverging? Here we use a test that I'm just going to call the telescoping series test, okay, to make a better way of describing it. Okay, we found the nth partial sum that was actually something we could put a number on, and we took that limit towards infinity. Okay, now that has to actually, there has to be a pattern for this to happen, right? The only way that this is going to work is if we have numbers that cancel out with each other, okay? Otherwise, we're talking about 1 plus 2 plus 3 plus 4 plus 5. Okay, it's not always going to happen that way. Okay, all right. The second test we're going to talk about today is actually one you have known since Algebra 2. What summation did you learn in Algebra 2? What types of sequences? You did it in pre-calc as well. What types of sequences did you work with in Algebra 2 and pre-calc? There were only 2 types. One was arithmetic, the other was geometric. Oh, good job. We got there.
Are these gonna work the same way as the integral B does, where you can write it above or next to it? Or is that specifically?
Oh, usually they're going to be underneath.
That's what I thought.
Here again and above. Here again when it switched to the new format.
It's okay. I'm losing sleep over it. I want you to know that.
Oh my god.
Okay, now you do notice that this starts at n equals 0.
Which
You'll
is
typically
not
see
bad.
that happening with a geometric sequence. It's like our one rule breaker, okay? Sometimes it starts, like when you discussed these in pre-calc, we wrote them like this, okay? But they're a lot easier to write when they look like this, okay? But you did talk about partial sums, which let's talk about. If I wanted a partial sum, we always can find it. Okay. No matter what A and R would be, we can always find the partial sum. Okay. Now, when we're talking about an infinite sum, then there's a rule about our R value. Anybody remember? What?
R.
Kind of. The absolute value is less than 1.
Oh yeah.
And I mean, just to put it out there, greater than 0. But R could be negative, but as long as the absolute value is less than 1, then we are going to be able to actually find that sum. Okay? Just since it's been a while, I want you to think of this scenario right here. Here's me, here's the door. I want to measure the distance of me to the door. Okay? So, I want to measure, how far of steps that I take, or the distance of my steps. So I'm going to cut the distance in half, and then I'm going to cut the distance in half again, and then I'm going to cut the distance in half again, and then again and again. Am I ever actually going to theoretically reach the door?
Oh, that's what a super task
No.
is.
But I'm going to get so close that I'm pretty much there. Okay? So when we have an infinite sum for geometric that meets this stipulation, we can say that it'll converge to this.
Is that a sub 1?
Well, no, just keep it as A for now. But I did write first term because there could be times where I give you a summation that maybe starts at 3, and you would want to make sure that the first term is when you plug in 3. Okay?
Oh no.
Oh no.
I am shaggy.
Okay, so this example right here is a geometric sequence. Or excuse me, it's a series because it's the sum of a sequence. But we have 3 plus 6 fifths plus 12 25ths plus 24 125ths. What's happening from term to term to term?
Well, the 3 is getting doubled, and then the 5 is going to another power.
Okay, so each term is getting multiplied by
I think
2 fifths. So when we multiply by the same number over and over and over, that's what we call a geometric sequence. Okay? So I need you to be able to recognize when the same number is being multiplied from term to term to term, we have a geometric sequence.
1225 is Christmas.
Oh, you are right.
So is
That is not even-
A 2/5?
No, R would be 2 fifths.
Oh.
Our common ratio is 2 fifths. So we would describe this as the sum from n equals 0 to infinity of our first term 3 times our R value 2 fifths to the n power. So let me ask you this. Is R less than 1?
Yeah.
Okay, so since this is an infinite geometric series and R is less than 1, we know that this converges because it's geometric and R, the absolute value of R is less than 1. That is what I would expect to see. Now, if I ask you to actually find the sum, then we would need
Plug in.
to take the first term divided by 1 minus R to actually find what the sum is. What's 3 divided by 3 fifths?
5.
So additionally, we could say that this converges to 5.
That's a clean number.
thoughts on that? We're going to work with geometric series a little bit more on Monday, and the different things visually we can view as an infinite series, which is kind of cool. But just FYI, we'll work more with that on Monday. And we'll do another example. But the third test I want to tell you about is the nth term test.
I have a question.
Yes.
If n reaches infinity for a fraction, how do you determine when something to the infinity is less than something else to the infinity? Because like 2/5 to the infinity would be 0, wouldn't it? Because the bottom would be infinitely large, but the top would also be.
What if you multiply it by
Now you're taking each when you square a fraction. You
So
square it.
this is kind of the case of infinity over infinity where that's indeterminate. Okay. So if a series I don't know why there's a comma there. If a series converges, then the limit of the sequence is 0. Contrapositive.
That's like geometry.
The limit is 0, then it converges.
That's not the contrapositive.
It's the
That's the converse.
it'd be like if a
If it
series
doesn't
does
equal
not
0.
converge to 0, then it's not a series.
We'll try this. It's backwards and negated. If not B, then not A. If A, then B, then it will always be correct. If not B, then not A. So, if the limit of our sequence is not 0, then our series will not be able to converge. It will diverge. And this, ladies and gentlemen, is the nth term test.
I think that's a false positive though, because you can have a limit as n, or like you can have a sum that's not 0, and
I didn't say the sum is 0.
the limit.
I said the limit of the sequence.
Oh, okay.
Yes.
A squared plus or minus 0.
It says
Does not equal.
Oh, I'm sorry.
Oh, I can see how that looks like.
Yeah, I
No,
thought that.
I was just kind of struggling there. I was like, what? Okay, that
Yeah.
makes sense. That makes sense.
Yeah, that's what I thought too. That was what was confusing.
Darby, could you assign us a code word, please?
plus or minus.
Thank you.
Wait,
Interesting choice.
So like the code
Which
word is
one?
one or the other. You can't say both. If you say both, you're wrong.
No, it's
plus
one word.
or
It's
minus.
one word.
Oh,
Plus
one
or
minus.
minus.
Plus or
Plus or
minus.
minus one word. Okay, now how quick is it for us to take limits?
Not that time.
Well, after we
Quicker
did
than taking derivatives, right?
after we did that one
Yes.
unit with the determinate forms, it's really
The first thing you should do,
Oh, I get it
the
because
first thing you should do is look at the sequence and see if the limit is 0. Because if it's not, you can't keep going with any of our other tests that we have.
I get it because if the limit isn't 0, then the final term of the sequence is going to be added, meaning that it'll be infinite.
uh-oh. Is it?
Or a question mark.
Oh, that's not what I wanted.
I think they are all questions.
What question mark?
It says convergent, convergent, or question mark? They're all question mark.
Hey, wasn't this like a dystopian teen series?
God, it was Divergent.
Write down the series.
Insurgent, Allegiant, and then they tried to make a movie and it was bad.
What, you
The
thought the
books were
books were
bad.
good?
Main character.
Thank God.
God.
I think I read the first one because I was pure pressure to do it, and the other one I was like, I gotta finish this series before it kills my soul. But
I have not.
their brother called it finesse.
My favorite is when they look like sideways.
What is this sort of
Okay,
a
but the
line?
brother, like
Like they need to be a little bit more along.
Like,
What is
You
this
know?
sort of a line?
Alright, so,
Is
is this a geometric series?
No.
No, it's not. Okay. What's the first thing I ask you to look at? The limit. So, if we were going to look at the limit as n approaches infinity of n factorial over 3n factorial plus 2, who thinks they know what this limit is?
Well, it's infinity over infinity.
It is. This is true.
Is it 2?
It is not.
Is it 1/2?
Okay, stop guessing.
1/5?
Well, the bottom's gonna be all
Simplify
words.
it.
Let's think about this. The polynomial in the numerator would have the same degree as the polynomial in the denominator.
So weird.
Where would the horizontal asymptote be?
1/3.
Yes.
Wait, so the 3 is a coefficient to the n factorial and
Yes.
not 3n quantity. Okay.
Yes.
Okay. I was like, it's just gonna be really big.
Okay. And since our limit does not equal 0, then
Is
we
it
say
really
that
a coefficient if it's a factorial?
the,
all
it's
intents and
3
purposes,
times n factorial.
Assume yes. Just for
So we say it diverges by the nth term test.
What if it passes all the tests, but it still diverges?
That would not happen.
Making a function that diverges but passes all the tests, and we need to make a new test.
By the end of this, you will not be begging for a new test.
Oh, that sounds like a threat.
I don't know if I don't think I consider that a threat.
You won't be asking
will
for any
soon.
more tests.
Oh, you want more tests? I'll give you more tests.
I think we're gonna end up with like 11 of them.
Are you serious?
Mm-hmm.
I know everybody loves this. It's 7th hour.
Okay. You could really go about this 2 different ways, couldn't you?
Well, I mean, you could just do the limit test.
We could do the limit and say that the limit is infinity, and so that's not. Right? But what specific kind of series is it?
You said it's geometric.
It's geometric. So without doing any work, we could say that this diverges
Because A is 0.
because it's a geometric, that's not why.
Oh, A is 1. That's right. Oh, that's, yeah, okay. Yeah, that's another valid reason.
Also, limit is also not
Oh, it's greater than or equal to? Okay.
Well, if
Key factor.
If to converge, the absolute value of r is less than 1, then to diverge, we would want the exact opposite, which would be greater than or equal to 1.
What if it's less than
I think
0?
I just wrote greater than 1.
Oh,
I'm
wait.
trying to look for where I wrote that.
Okay?
The
You
absolute-
probably wrote absolute value of r less than 1, unless you made an extra note to yourself.
If R
I
equals
just like
1,
that.
then it's just infinity times A, right?
Well, if r equals 1, there again, we don't have a converging series.
Yeah. It
Okay?
would just be infinity A. E A. Syndicated. Funny meme. We care about giving. What did they say?
You said something with a bi-battle friend.
Okay, is this geometric?
No,
No.
I don't
Okay.
like it.
Join the club. Okay, I don't like read all like nice little bracky looking things in the signal, but I'm also like,
So, the first thing I tell you to do is to check the limit.
Well,
And
it's
what is
zero.
the limit of the sequence?
It's 0.
Hey, that's good,
wait a second.
but it actually doesn't tell us anything.
Dang it.
What?
Dang it. Our plans have been foiled.
It means we know nothing.
It means that the final
Right.
term is 0.
No.
I
It means that the
Oh,
sequence Okay? But we know nothing. Now, this is not telescoping because we don't have like if we looked at our sum, right?
It
We
would
would have-
be 1.
Can I teach, Joe? Can I teach? 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 all the way to n. Like there are no patterns in there for us to be able to like take the limit of our sum. So we're kind of screwed until we have more tests.
No, you're gonna give us another test.
I mean, technically, didn't we like?
No.
Question mark one.
Oh,
Yep.
dramatic.
Didn't we do that earlier and we integrated to infinity? Like
Yeah,
that was
then it
the
was
same.
Do you think there's going to be a connection to that?
No, 1,
Yeah.
2.
No, Jackson, why'd you say?
Jackson is right. This is going to be a divergent series.
What? Oh man.
Even though the limit is 0, this will end up being divergent. But I haven't taught you how to prove that yet. So we'll just wait until Tuesday.
Oh, you
Because
can tell
Mrs.
it
Holmes
obviously
said so,
goes
test.
beyond 1.
Because Mrs. Holmes
1/2
said
plus
so.
1/3
Okay,
plus
does anybody
1/4.
know what kind of sequence 1 over n is?
Series.
Is it the horn thing?
G series?
Well, I mean,
Sub 2 period.
you're right. It is.
Yeah,
But
okay.
specifically,
No,
1 over n is the harmonic
he said like
series.
G.
Because of music stuff, like with the 1 and 1/2 and 1/3 and 1/4. Relates to
Do
music.
you have a music minor?
All right. So your homework, you have 10 minutes to begin. So I want you to get 3 problems done before you leave.
Telescoping problems are like all of the fancy math club competition ones. Those are the ones you see pop up.
Is convergent a word?
Yeah.
Infinite.
Yeah.
Look at this.
Oh yeah.
Oh wow.